Hey guys, today we're doing polynomial division and factoring. So you will be able to perform polynomial division, explain the remainder theorem, and the rational roots or zero theorem. You will be able to divide polynomials using both long division and synthetic division and connect polynomial division to factoring. So when we are talking about dividing polynomials, we have to do that the same way we would be dividing integers or other expressions. We need to reduce common factors to 1. So in order to reduce common factors, we need everything to be attached by multiplication. So I'm going to factor our numerator to x plus 3 times x minus 2. And I cannot factor my denominator, so I'm going to keep it as x minus 2. I then look for common factors in both my numerator and denominator and see that I have an x minus 2 in both. So x minus 2 divided by x minus 2 cancels to 1, and I am left with x plus 3 as my answer. We also divide polynomials using long division the same way we would arithmetically divide using long division. So we are going to first divide our leading term of the dividend, which is 2x squared, by the leading term of the divisor, which is x. So we think, what do we need to multiply x by to get 2x squared? And that would be a 2x. We're then going to multiply, just like we would in regular long division, 2x times x to get 2x squared, and subtract it. This cancels to get 0. We then multiply 2x times 2, which is 4x, subtract it, subtract 4x. So 6x minus 4x is equal to 2x. We now have to think about, what do we have to multiply x by to get 2x? So, what do we have to multiply x by to get 2x? That would be plus 2. So 2 times x is 2x. We're going to subtract, and we cancel and get 0. Then 2 times 2 would be minus 4. So 5 minus 4 is 1. So there is a remainder of 1. And similar to when we divide whole numbers, the remainder is written as a fraction with the remainder over the divisor, or what we were dividing by. So it would be 2x, our solution would be 2x plus 2 plus 1 divided by x plus 2 as our answer. Now, the remainder theorem is telling us when a polynomial f of x is divided by a binomial x minus a, the remainder is the value of f of a. So if we just divided 2x squared plus 6x plus 5 divided by x plus 2. And we got that there was a remainder of 1. So in order to put this in terms of x minus a, we would have x minus negative 2. So let's check if that's right. That means we have to plug in negative 2 into our polynomial. So f of negative 2 is equal to 2 times negative 2 squared plus 6 times negative 2 plus 5. So f of negative 2 is equal to negative 2 squared is 4 times 2 is 8 minus 6 times negative 2 is 12 plus 5. And our solution of f of negative 2 is equal to 1, which is in fact the remainder we got when we divided by x plus 2. The rational roots theorem, which is also called as the rational zeros theorem because roots and zeros mean the same, tells us that given a polynomial equation in the form an x to the nth power plus an minus 1 x to the n minus 1 plus a2x squared plus a1x plus a0 is equal to 0, with integer coefficients telling us that all of these a's are standing for integers, the rational roots of this equation will be in the form of p over q, where p is a factor of the constant term. So p is any factors of the constant terms a0, and q is the factor of the leading coefficient an. So if we try one of these, it'll make a little bit more sense to us. So we have our polynomial equation, 3x squared minus x minus 10. We want to know what is the constant term, and the constant term is 10. What is the leading term? The leading term is 3. We're going to find the factors of both 10 and 3. So the factors of 10 are 1, positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. Then the factors of 3 are positive and negative 1, and positive and negative 3. So, we can test each possible root by plugging it into the original equation. Then, if we get the result, you'll have found your roots of our equation. But first, we're going to find all of our possible roots. So in order to find all of our possible roots, we have to find all of the combinations between this. So we have plus or minus. We're going to divide by 1 first. So we have plus or minus 1, positive or negative 2, positive or negative 5, and positive or negative 10. We then divide by positive or negative 3. We have positive or negative 1/3, positive or negative 2/3, positive or negative 5/3, and positive or negative 10/3. So these are all of our possible roots, and if we plug them into our original equation, and the result would be 0 if it was a root of the equation. And the last thing that we're going to do today is synthetic division. And synthetic division is a way to divide polynomials by a binomial in the form of x minus a, where a is a constant. So if we look at cubed minus 2x squared plus 7x minus 10 divided by x minus 2. We set up synthetic division with this upside down empty box, and we fill in our coefficients of the polynomial. If we have a missing value, then we would plug in 0 as that coefficient. So we have to make sure that we're writing our coefficients in order with our highest power. So we're going to start with the highest power of 3. The coefficient is 1, negative 2, 7, negative 10. Outside of the box, we're going to write the value of a from our binomial that we're dividing by. So since it's minus a in our original rule, all we need to look at is that 2. So we're going to write 2 on the outside of our box. To carry out the division, we are going to start off by bringing the 1 down on the outside of the box. We then multiply 1 times 2 to get 2, and we place that in the next column over. We add the second column. So negative 2 plus 2 is 0. Then 0 times 2 is 0, and we place that in the next column over. We add the column down, so 7 plus 0 is 7. We then multiply 7 times 2, which is 14. Negative 10 plus 14 is 4. Now it's time for us to interpret the results. The numbers underneath the box represent the coefficients of our quotient, or our answer. So, the first term of the quotient is 1 degree less than the polynomial that we were dividing. So the highest degree we had was 3. So now our answer is going to have the degree 1 less. So it will start off with 1x squared. Since there's a 0 in the second column, that means there's no x term. It could be plus 0x, which just means plus 0. So that does not exist. Then we have the constant term plus 7. And the number in the last column is your remainder. So that is plus 4 divided by x minus 2. So our quotient of this problem was x squared plus 7 plus 4 divided by x minus 2.